Welcome. Today's notes worksheet is entitled Families of Functions, and we will be taking a look at a variety of functions graphically in just a few minutes here and look at a few of the characteristics that go with them. And then what we'll do is switch gears and look at one particular type of function just from a more graphical perspective and then from a problem-solving perspective. So some good math to be had here. Well, why don't we go ahead and dive in. In fact, the whole front side should really just take us a few minutes. A variety of types of functions that we should be comfortable with. We'll go ahead and just graph the most basic one of each family, and then go ahead and just throw a little domain and range in there. Be great if you can work half a step ahead of me on this, and see what you can fill in, and then kind of just confirm with what I do up on the board here. So let's get started. First of all, linear functions, just mx plus b. I think we're all comfortable with seeing what that looks like, but just to kind of get us in the groove here. I'm going to go ahead and just graph y equals x, just the most basic linear function, and I'll go ahead and zoom standard this. And so it should just look something like that, of course. Slope of 1, y-intercept of 0, etc., etc. Guys, no tick marks necessary here. Should just be comfortable with each of the graphical patterns from these families that we're going to see. So linear kind of speaks for itself. If I were to ask you to come up with a domain and range of these functions, I'm hoping you would agree with me that the domain is all real numbers and the range also all real numbers. So really mx plus b there, as long as the slope isn't 0, this really should be the case. Domain and range all reals, of course. Great. The next family of functions that we do a lot of work with would be the quadratics. So let's go get going on those quadratics here. Again, the most basic one is just y equals x squared. So if you can, please just go ahead to your calculator and throw in the y equals x squared and just hit graph. I'll do that as well. And of course, we get our nice looking parabola. So again, just a nice coordinate plane. There we go, parabola looking like that. Perfect. Same deal, everyone. Would love for you to come up with the domain and range here and then confirm with what I put on the board. I'm getting a domain of all real numbers. I can take any number and square it, of course. But the range, certainly my outputs, seem to be just going from 0 and above. So hoping everyone is getting really good at analyzing graphs, being able to think horizontally for the domain and think vertically for the range. And in here, of course, I only see the graph coming down and up, down and up. It looks like, of course, only from 0 and above. Okay, cubics. Let's go get those cubics, all sort of in the polynomial family. So this would be linear, quadratic, cubic, quartic, etc., right up the line. Then here we go, just a nice cubic. Probably done some work with those before, and looks pretty good. Let's go ahead and sketch that in place. So it should look something like this, give or take. And in terms of the domain, thinking left to right there, again, you have to extrapolate a little with these graphs, but you can see going left and right, it's going forever and ever. No stops, no breaks, nothing like that. And I think vertically you can all see, of course, that the domain, that the range would be all reals as well. Okay, good. We're going to do a little work with the square root family coming up, so should be comfortable with the graphical pattern of a square root function. So let's go ahead and get that in place. If you can go ahead and do second, and then there we go. That one right there, and just square root of x. So I'm going to go ahead and hit graph, and you get something like that right there. And again, should be fairly comfortable with understanding that this is the graphical pattern that emerges from a square root function, looking something like this. And then could you come up with the domain and range as well? Well, let's see. I have a domain. And we've kind of talked about this algebraically, but I see it graphically too. The domain seems to be anything that's positive or 0, and that makes sense with what you can see here. So can't take the square root of a negative, and there's our domain that would reinforce that idea. And in terms of the range, thinking vertically, it looks like I'm only from 0 and above, so I'm getting a range of greater than or equal to 0. Nice. Again, we're going to work with these functions a little bit when we do what is called transformations. So keep this graphical pattern in the back of your mind if you don't mind. We're going to change that up a little bit and kind of work with those types of functions. All right, 4 down, everyone. Let's go get the remaining 4 here. Let's do a little work with the rationals. And so these are sometimes a little tough to see graphically on these calculators, but we'll go ahead and sketch it in nonetheless. So I have 1 divided by x. I'll hit graph right there. And again, it's not probably the ideal window, but it will have to suffice. And so here's what I have, everybody. Should look like a nice hyperbola, something like that right there. So let's see if we can come up with a nice domain and range for this function. It looks like horizontally, we've seen this before, I got a little break, kind of jumping over 0. And remember that restriction, of course, I can't divide by 0, so 0 would have to be excluded from this domain. And hopefully you can also see this vertically as I come up. It's really plateauing, getting closer and closer to 0, but then there is a jump, and then we pick up the rest of the graph. So I'm getting these two values as in terms of domain and range. Okay, good. Absolute value, that's the one that we'll take care of next here. We'll see absolute value primarily when doing our transformation. So again, just kind of keep this graphical pattern in the back of your mind as well. So let's go ahead. I'm going to clear that out. And when you get a chance, everyone, go ahead and hit math for me and move it over 1 to the right. And there it is at the top, ABS, so absolute value of x. And I type that in and hit graph and the V shape. So absolute value functions form a V on the coordinate plane. And again, we'll kind of manipulate that when we do transformations. But that would be the family of functions that produces that graphical pattern right there. I'm seeing a nice good domain and range. Here we go. I've got all reals in terms of the domain. And it looks like I am from 0 and above on that range. And that's looking pretty good so far. All right. Now these two are kind of tied at the hip. So an exponential growth function with a base 2 and what's called a logarithmic function, also base 2. And so we will do some work with these in the near future. But for this context, it's just getting comfortable with seeing the graph and maybe coming up with a couple characteristics for it. So let's go ahead and type in that nice exponential growth function, y equals 2 to the x. And so I'm going to go ahead and write there, y equals 2 raised to the x. And I get that piece. Again, not an ideal window. If I trace this out, everybody, which I will not, but if I did, we would see that this does continue indefinitely to the left. And it gets closer and closer and closer to that x-axis. So something like this, give or take. I will leave that to your discretion on how you graph that, but it should look something like that. Domain, definitely all reals. As I go left to right there, it just keeps going. No stops, no breaks. But range, it looks like it's only above the x-axis. As a matter of fact, as this keeps going to the left, it will never, ever, ever touch that x-axis. And so as a result, no or equals here, everyone, just greater than 0. This one's also a tough one to see, this last one, what's called a logarithmic function. We'll go ahead and type it in exactly as it says right there. See if we can figure out what it looks like. But I'll sketch it out so we have a good way to see it. So what we want to do here is type in log of x and then divided by log of 2, as it says on your paper. So I'll go ahead and do that. I've got one extra. Maybe something like that, and let's see if this plays out. I'll go ahead and hit graph, and again, it's not ideal with this window, especially as I kind of get in here, but I will show you what happens as a result. So a little different than the square root graph, but similar in nature, similar, but definitely some differences. So that's really what it would look like right there. And that graph, again, it was tough to tell from the calculator, but as I kind of look at it going in this direction, it's getting closer and closer and closer to the y-axis. Would it ever touch or cross? No, no, absolutely not. So as a result, when we talk about our domain, it looks like I'm only to the right of 0. Hoping you see that piece. That's an interesting one. So as a result, x is greater than 0 is the domain. And in terms of the range, this is going down infinitely, going up infinitely, if you can extrapolate there, and no stops, no breaks. And as a matter of fact, all reals. Just one quick note, and then we'll move forward because it's not important right now, but it will be at some point in time with our curriculum. If you look at the domain and range here, and look at the domain and range here, they are switched. And again, that is not a coincidence. The relationship between these two functions kind of dictates that. And we'll get that to that in good time. All right, good. So again, guys, this front side is really just getting comfortable with different families of functions and recognizing the graphical patterns that they make on the coordinate plane. Okay, let's go into our next one then. Let's see here. Okay, so number 9 is what's called the piecewise defined function. And so we're going to go ahead and see if we can break this up as much as possible, do some things graphically and algebraically, and then one great application towards the end. So here we go. A piecewise function is a function defined by 2 or more equations. And everyone, if you don't mind, can you underline this piece? The use of the equation is based on the domain. And so really we've been talking about domain lately quite a bit. And so now what we're going to do is sort of break a function up into different parts. And the usage of those parts is based on the domain interval. Okay, so this one, as you can see, it's one function. So f of x, or y equals, and the function is broken up into 3 parts. We would perform these algebraic rules if our inputs are less than 0, so if x is less than 0. We would perform this algebraic rule if our inputs are between 0 and 2 inclusive. And we would perform this algebraic rule, or really just get an output of 1, if our inputs are bigger than 2. So again, this dictates which of these we would use. So let's see if we can portray this graphically, then kind of work with it. But just one thing to note, it is a function. In fact, it says it right here, graph this function. So when we graph this on the coordinate plane, everybody, just don't forget, it should pass the vertical line test. Let's be very clear about that. It is a function. Okay. Well, let's do this. Let's just kind of get us thinking about it. It looks like it's broken up into 3 parts based on these 3 domain intervals. Let's show that graphically initially here. Now, again, this is not part of the graph. Let me be clear on that. So as light as you possibly can, let's get a boundary, because it looks like I have a break kind of at 0. So when x is 0, that, by the way, would be just the y-axis coming down. As light as you can manage, just kind of dot that. Just, again, barely touching the paper, but just so you know it's there. And then we have another break, sort of different definitions, when it's less than 2 and greater than 2. So let's go over to x is 2, and let's do the same thing. Again, barely touching your paper there. Just kind of do that piece. So that is not part of the graph at all. Just keep that in mind. It just sort of gets me thinking about, I'm going to have one graph to the left of that vertical line, one graph in between it, and one graph to the right of that vertical line. Okay, so let's go ahead and try this out. I'm going to bring up my calculator and encourage you to do the same. So the first part of this, the first graphical piece that we have to figure out is from the 2x plus 3. Now we should all pretty much know what 2x plus 3 looks like. Y-intercept of 3, slope of 2, looks great. And here I guess would be the quick question as we look to translate this over to the coordinate plane over here is, do I want to graph the entire line on this coordinate plane over here? If you've been paying attention and kind of see this piece up here, you would say probably not. I only want to apply this part of this graph to the part when I am to the left of 0 or less than 0. So in terms of x being less than 0, what that means, everybody, is I'm to the left of 0. And so we drew this in this little boundary right here to help us out. But essentially, I just want to the left of 0. So what that would look like, everybody, is here's 0. I just want to the left of that. Hope that makes sense. Okay. Now we're going to do a little open dot and close dot, by the way. So just use your intuition and your background with this. But if it's not equal to 0, but all the way up to it, just not including it, we would do what's called an open dot. So everyone, if you would, go up to positive 3 on the y-axis, and I need an open dot right there. So that's where the line would cross 0 if it went all the way through. But we just want the part that is to the left of 0. And so here we go. I'm going to go ahead and now draw my graph to the left of 0, kind of looking like that. And that'll have to work. That's it. So again, this line just to the left of 0, or as it says on your paper, when x is less than 0. All right, I hope that works. Now on to the next piece. In between our two boundaries. So right in here, we want to apply this algebraic rule. And so let's go ahead and see what that looks like graphically. And I'm going to go ahead and type in y equals x squared, and we pretty much just did that on the front side. But there's the parabola. Sorry, I have to ask the question, do we want to graph the entire parabola? Nope, absolutely not. Only the part that'll fit right in here. So only the part from 0 to 2. So only the part in between 0 and 2. I hope you can see that visually as I'm portraying it on the screen. So rather than doing the entire parabola like this, that wouldn't make sense. We only want it in between here and here. By the way, notice equal to 0, equal to 2. So in this case, we do want to include closed dots. So we want to include the parabola all the way up to and including 0, and all the way up to and including 2. So by the way, this would look something like this. I think it would be 2 squared is 4. So this would be the parabola, or the part of the parabola that would work. Closed dots, everybody, right there and right there. Okay, good. Notice so far, everybody, it's passing that vertical line test. As I said, it is a function, so it should. Draw a vertical line anywhere, and it's only going to pass through one point. Even here, guys, because it's not defined there, so it's not passing through the function there, it is passing through the function here on the closed dot. Defined here, not defined there. Okay, last piece. Again, kind of the third component to our piecewise function is just 1. So let's see what that looks like graphically. It's just a horizontal line all the way through. Again, I'll ask it, do we want to graph the entire horizontal line? No. Only to the right of 2. So only from here on over. And so think about it. Do you think it'll be an open dot or a closed dot when x is 2? And I'm hoping you came up with the conclusion that it would be an open dot and in a horizontal line, looking something like that. And as a matter of fact, that is your graph of this one function broken up into 1, 2, 3 parts. And those 3 parts are based on these 3 domain intervals right here. To the left of 0, here we go everyone, I'll try to get this going. To the left of 0, in between 0 and 2, and to the right of 2. Okay. I hope that works. If there are any sort of questions with putting that together, let me know. You can actually graph piecewise functions on the calculator. They're quite difficult to do. It's sort of very inconvenient, as a matter of fact. So if you want to take a look at that, I can show you how to graph all 3 parts here on the calculator, and you'd be able to kind of see this piece. But it looks great. All right, cool. Let's do example 1 here and then keep this moving along. So example 1, it says use the piecewise defined function from above to determine the following function values. So f of -4. Now a couple things to note with this. This is sort of intriguing, and it brings up a couple ideas conceptually. Remember how functions work, everybody. One input produces one output. So -4 goes in, only one thing can come out. Not 3 different things. You don't put it in here and here and here and try to get 3 different answers. That doesn't make sense. That doesn't work. It goes in one place and produces one answer. So I guess I would ask you this. What would be your intuition here? Where do you think that -4 is going to go? Do you think we're going to put it in here? Do you think we're going to put it in here? Or will it just be 1 from here? Well, if you think about this as an input, as an x value, -4 only fits one of these 3 domain intervals. -4 is less than 0. It doesn't make sense here, and it doesn't make sense here. So it says if it's less than 0, we do this. And so -4 is less than 0, so everyone, you put -4 right in here. So anyway, oops. Sorry about that. So that -4, it looks like, is going to go in for the x right here, and I would perform these rules. 2 times the -4 plus 3. And 2 times -4 plus 3 is definitely -5. Input, output, x and y. As a matter of fact, it should show up graphically here. If I go 1, 2, 3, 4 horizontally, 1, 2, 3, 4, 5 vertically, there it is. There's the point. Matches up perfectly. So there should be some continuity here. All right, let's run these others off. Letter B, f of 0. It goes in one place. So the question is, do you think it goes in the top? Does it fit this domain interval, the middle domain interval, or the bottom domain interval? And f of 0 looks like it fits this one right here. So I go right over here. And if it fits this interval, I'm supposed to do this function rule, this algebraic rule, I should say. 0 squared, 0. And by the way, there it is graphically, 0, 0. That's where it was defined. Nice. Not up here. Absolutely not. Next one, 1.5. So what do you think? 1.5 less than 0? No. 0 less than or equal to 1.5, less than or equal to 2? Yeah, that's the one. So it's in between 0 and 2, so it goes right there. 1.5 squared happens to be 2 1/4. All right, and again, just to kind of check it out, be somewhere in there, give or take. And last one here, f of 5. So which domain interval is it? Top, middle, bottom, and 5 is definitely bigger than 2, so it's the bottom one that makes it true. And so as a result, no matter what that input is, the output is always 1. And let's go ahead and find it. 1, 2, 3, 4, 5, 1. There it is right there. So I'm hoping you kind of see that that matches up. I like that one piece. Input produces one output. Okay, guys, let's go to example 2. Be great if you could pause the video and do this one and see if you get it. Here's what I would start out with before you actually pause it. One function, so f of x, or just y equals if you want. I don't know how to make a bracket to save my life, so I just do some squigglies right there. And then think about how many different breaks there are, so how many different domain intervals, how many different algebraic rules, and kind of go from there. How many levels to this piecewise function? Okay, well, let's see how you did. The first thing I do, by the way, and you might have done this intuitively, I realized there were 2 parts to this. It looked like here and here. So 2 parts means 2 levels to my piecewise function. So I do this right away. It seems kind of weird, but I do 2 ifs, just kind of in the middle there. And then I kind of think about what the domain intervals will be. So I do this first. And what I see, everybody, if you can kind of see this up here, it looks like this graph is to the left of 0. This graph is to the right of 0. And so as a result, I should have my 2 domain intervals. So 1 is to the left of 0, but not including 0. 1 is to the right of 0 and including 0. So I do want to go ahead and dictate it that way. And that's looking great. And so now all I have to do is come up with an algebraic rule for each piece. What do I want to accomplish if x is less than 0? And what type of rules would we need to perform if x is bigger than or equal to 0? And so the way I saw this, at least, and maybe you saw the same, is just even though it doesn't go all the way through, of course, this does form a linear pattern on the coordinate plane. And the linear pattern comes from the algebraic rules, mx plus b. So all I did was kind of think of the slope and what would be the y-intercept here, and just wrote my mx plus b. I'm seeing this as down 1, right 1, down 1, right 1. I saw a slope of -1. I hope you all agree on that. So I'm getting a -1x, and even though it doesn't officially hit the 4, that's where it would hit the y-intercept. And so as a result, -1x plus 4. And you could try this. Put in a couple x values that are less than 0, put them in here. And do they match up with the graph? They should. Okay, this one. Also, again, I know it's kind of cut off here, but this is a linear pattern on the coordinate plane. So totally mx plus b all the way. And I'm seeing a slope of up 1 over 2, up 1 over 2. And so I'm seeing a 1/2 x. And it does actually hit, it looks like, right there at +2. And so as a result, I think that's it. And that's nice. 2 different parts to the graph means 2 levels of my piecewise function. I like starting with this, then I do this, and then I do this last. Okay, great. Let's do one great application. Try to break it up as much as possible, and then write one nice piecewise function for it. Here we go. By the way, this is completely analogous to the United States tax system. on a much more simplified version, but it is analogous nonetheless. So let me read through the problem and then we'll go for it. A country taxes the first $40,000 of an individual's income at a 12% rate, the next $50,000 of an income at a 23% rate, and any income above $90,000 at a 35% rate. This is what is called a progressive tax system, and it's based on the ideology that the more money you make, the greater percentage that you would pay in taxes on that income. And so as you can see, the first $40,000 is at the lowest rate. The next $50,000, the rate goes up, and then anything above $90,000 gets taxed at this highest level right here at 35%. And what we're going to do is actually write, as you can see maybe at the bottom of your page there, what we're going to do is write a function to calculate the tax for anybody's income. No matter how much they might make, you're coming up with an algebraic rule in order to pull it off. Okay, well let's start it out. If letter A, it does say how much tax would you pay if your income is any amount between $0 and $40,000. So that first $40,000, as you can see, is taxed at a 12% rate. So whatever income you make, they are going to go ahead and take 12% of that. And by the way, of means multiply, just FYI. So if your income is X dollars, what they're going to do is take 12% of that. So essentially, 12% by the way is 0.12. They're going to do 0.12 times X, and that's how much tax you would pay on that money. Okay, hope everyone's clear on that piece. Okay, now the next, letter B. If you earn more than $40,000, do you still pay 12% on that first $40,000? Ooh, great question. Put a little asterisk by it. Conceptually, this is huge if we're going to be successful here. So what is the answer? If we earn more than 40 grand, do you still pay 12% on the first 40,000? Yes, you do. So you only pay the next rate for money above 40,000. Okay, I hope that's clear. So let's break this on down a little bit. Knowing that that's the case, you pay 12% on the first 40,000. What happens when we start to make more money than $40,000? So guys, let's go in and see. If you earn $50,000, how much of that income is taxed at the 23% level? Not all of it, not all of it. So remember, the first $40,000 is taxed at 12%. Only the money above it. So I'm hoping you're okay with me saying that only $10,000 of that 50 would be taxed at the 23% level. If we earn $60,000, what do you think? How much of that income is going to be taxed at the 23% level? Only 20,000 of it. The first 40 is taxed at 12%. Only the next 20 is taxed at 23. How about this one, everyone? If we earn $70,000, how much of that income is taxed at the 23% level? I'm hoping you would agree that it's $30,000. Okay, so the first 40 is taxed at 12%, and then for this one, the next 30 would be taxed at the 23% level. Now, let's see if you can generalize. It says, write an expression for the tax paid on income between $40,000 and $90,000. So this would be the middle level in this three-tiered progressive tax system. Okay, now you're going to pay 23% of it, no matter what. So just this part. Forget the first $40,000 for right now. We'll come back to that piece. But you pay 23% not on X. So let's be clear, that is not correct. Because I don't pay it on all the income, only on the money above $40,000. So as a result, think about the calculation that you did. If this is X, if this is your income, what did you do to figure out how much is taxed at the 23% level? Well, guys, 50,000 minus 40,000 is this. 60,000 minus 40,000 is this. 70,000 minus 40,000 is this. And so as a result, it should look something like this. I take that income and I subtract $40,000, and that's what's taxed at the 23% level. Okay, good, super. Again, we're just answering some good preliminary questions before we attempt to put it all together. Let's go get the next piece, everybody. Letter E. So it says, if you earn more than $90,000, all right, so we're starting to earn the big money here. Do you still pay 12% on the first $40,000? And would you still pay 23% on that next $50,000? Again, a little asterisk if you would. And what is the answer to this particular question? If you've been following along, I think you can only answer yes. So the way this tax system works, we pay 12% on the first 40, we pay 23% on the next 50, and then we start to pay 35% just on the money above 90,000. So that gets us into F. So let's think about it. If we earn six figures, if we earn 100,000, how much of that is taxed at the big level, at the 35% level? Not all of it, as we've seen. Anything above 90. So I'm hoping you would agree. That's how much is above 90,000. Only the money above 90,000 is taxed at this level. So if we make 130,000, not all of it is taxed at this level right here, just the money above 90,000. And so think about it. If I take this and just subtract 90,000, I get that right there. Keep that calculation, by the way, in the back of your mind. How about this one? If we make 200,000, again, not all of it is taxed at the 35%, only the money above 90,000. And that's how much of it is above 90,000. So it says, write an expression for the tax paid on income above $90,000. It's 35%. And I'm hoping you saw in each case, when I gave you an income of X dollars, whatever it may be, either this or this or this or anything above 90,000, the first thing I would do is subtract 90,000 from it. That's how I figure out how much is taxed at the 35% level, and then of course, I multiply it by 0.35. So in this case, if we make 100,000, I would only tax the 35% on 10,000 of it. I hope everyone's clear on that piece. Well, there's no time like the present, guys. It's time to put it all together. So notice what letter H says. Write a piecewise defined function for an individual's tax. So we'll call this tax in terms of X. And so T of X in terms of the income, and the income is going to be our input, our X dollars. So can you find a mathematical way to calculate anybody's tax based on their income? Well, everyone, give me a big T of X if you would. And I can't do brackets, but if you can, do brackets. There you go. That's my poor excuse for it. And the question I guess I would have for you as we start this out, and we answered all these questions, how many layers, how many levels to this piecewise function are we looking at? And I see three. I see three layers. So three different percentages based on three different incomes. So what I do right away is I just do three ifs. Just kind of gets me thinking in the right direction there. And I'm going to try to fill all this in if possible. In fact, I might change this up just a little bit. Move this over. My apologies. I'm going to need some space, and you will too. So I'm going to come a little further out here. So three ifs, everybody. Excellent. Now let's talk about that. Let's talk about our domain our domain intervals, which would be our income intervals. And I hope you would agree there's one way to calculate a tax if we make between 0 and up to and including $40,000. That first $40,000 is taxed a particular way. Okay. Now, after we make more than $40,000, the next percentage kicks in on that money, and it's from $40,000, not including it. Notice if I included the $40,000 here, I don't include it here, up to and including $90,000. So that was the next 50, from 40 to 90. That's the next 50. Okay, and then there is a third way to calculate the tax if we start making more than 90,000. So as I said, figure out how many levels, 1, 2, 3 levels, so 3 ifs. Then think about the domain intervals, in this case, income intervals. And now, let's see if we can do it. The way I've always categorized this, it sort of goes easy, medium, hard. So all the answers, I guess, maybe indirectly, but all the answers are kind of above on what we did A through G to help us pull this off. So let's think about this. This one I think we wrote explicitly, and I think you would know. If we make less than $40,000, how would you calculate the tax? And if you look at the description, I have my paper right here. It says, a country taxes the first $40,000 of an individual's income at 12%. So whatever money you make between $0 and $40,000, and that's your X, that's your variable, it gets taxed at 12%. And that was our answer, I believe, from letter A. Okay, now everybody, it would be great if you could pause the video for just a moment and try to do the middle layer here. And specifically, look at the answers, really B through D, specifically B and D. Well, let's see. Here's what I thought of. If you kind of look at this, if we start making more than $40,000, I do have to first acknowledge that I pay 12% on that first $40,000, right? If I've made more than 40, then my first $40,000 is all used up and taxed at the 12%. So that's what we answered in part B. If we make more than $40,000, is the first $40,000 taxed at 12%? And we said yes. So I pay 12% on the first 40. Then, guys, then I start paying more tax on the income above it. And the next percentage kicks in, which I believe was 23%. That next percentage kicks in, and again, look at your answer in D, for only the money above $40,000. Gets pretty tricky, doesn't it? So look at that for just a second, and let me try to translate it verbally. We make more than $40,000. Great. So the way this is defined is you pay 12% on the first $40,000. There it is, guys. There it is, written in stone. And then 23% on just the money above the $40,000. I have a way to maybe show you this visually if this doesn't click for you. So please, certainly ask questions if you have, especially on this layer and then the last one. Okay, so I've got 2 in place, and then it's time to start thinking about the third. So if you would, look at your answers from E through G and see if you can pull it off. This is definitely the hardest by far. Well, here's what I did. So we're making the big money. We're making more than $90,000. And the way this works is I work my way up. So if I make more than $90,000, it means, oops, hang on just one sec here. There we go. So if I make more than $90,000, it means I've made that first 40, of course. And I certainly pay 12% on that first 40. Now, if I've made more than $90,000, here is the real trick. Here's where I've seen issues over the years. But if we've made more than $90,000, it means I've made all of the $50,000 taxed at that 23% level. So let's think about that for a sec. You've made more than 90, right? So 12%, I should say this, $40,000 is taxed at the 12%. Your next $50,000 is taxed at this middle level, the 23%, and then just anything above it is now taxed at 35%. All right, so what would that last piece look like? I'm sorry, I'm going to have to come right down here. And the 35% kicks in on just the money above $90,000. And that's what it would look like. This is what I've seen students struggle with the most, right in there. And here would be my way to describe it as best as I know how, is if you've made more than $90,000, then you have made all $50,000 being taxed at the 23% level. And so as one constant, 50,000, it's all taxed at 23%. Woo, that looks great. So please, guys, especially on the second layer and the third layer, ask questions if you have them. But if I gave you any tax now, you would figure out which domain interval it fit, less than 40, between 40 and 90, or bigger than 90. And whatever domain interval it fit in, you would know exactly where to put it, either here, or here, or here, and perform the calculations. All right. I've got a few good applications to try to get some practice with this, so please try it out. Some great high-level mathematics in there. Well, thank you for listening, of course, and please let me know if you have questions, especially on that last one.